Good afternoon, everyone, okay, in the class and online. So this is the introduction to computer science. Okay. So my plan today. Can you hear me well online?
Yes.
Okay. So my plan today is to continue what our discussion about the function, and then a little bit about class, and then we will discuss about the design of the software using a diagram called UML diagram. Okay. Uh, I hope we can finish some of it. Okay. Okay. We. So our last discussion is about function, right? Well, you need to open your laptop physically. Okay. So our last discussion is about function, right? So what this function is just a mini program. Okay, consists of several statements, and we call them a single within a single function name. Okay. Once we call that function name, for example, f in here. Okay. So f with the input of a and b, and then you return a plus b. That means now if you give input of 2 and 3, then 2 plus 3 is 5. Okay. So by calling the name of the function, okay, you can get this automation done. Okay. So we also discussed last meeting that function not necessarily have return statement. Okay. Sometimes you don't return anything. And then if you want to have a default value for the input, you need to put it at the end. Okay. So in the beginning, all the parameters in the beginning of the function uh, are not optional. Okay. The optional uh, parameter of the function must be at the end. And then we talk about the scope, right? So there are scope that is global, that outside the function, and there is scope that is actually local, which is inside the function. So that was our last meeting. So is there any question about those functions and scoping? Okay, so sometimes you have a function that actually uh, you want to defend yourself. So this is called defensive programming. You want to defend your function against mistake in the input, right? So in that case, you can also use this syntax. Yeah? Try, except, okay? Uh, so when you say try, and then colon, and then you do some code in here. Example here is a plus b plus c plus d. So if there's an error, okay, if there's an error, then the exception will do. This is the exception. Okay. This is the possible name of the error. If there is this error, then this code will be implemented. Okay. This is similar to if then else, right? But the only difference is it only happened during error. Okay. So let's practice this. You can open your Jupyter notebook or your Spider. Okay, so I will create a new one. Okay. copy this one. I'll put it here. So if you look at this, we define the function, we try and accept, okay, and then now we want to put f1, right? This is f1. F1. So I will put just F1. What will happen? Oh, there's a missing argument with this A and B. Okay, so I will put A and B is 1 and -9. Oh, it will give me -5. Where it come from? Where it come from? A is 1, B is -9. So if I add with this, become -8, right? And then C is already given there, so 3. That's why you get -5. Okay. So let's say you want to do something that is error. Eh? So instead of 1, I will say this is A or ABC. Right? So you cannot add a string with numbers, right? Okay. But in here you can. Okay. What is the result? 0. Yeah. Why this is 0? Because there is an error, right? Why? What is the error? You cannot add string with numbers. Okay? There is an error, so this line of code number 3, okay, will not be executed. Okay? Directly execute line 5 because there is an error. Is it clear or not? Okay. Oh, is there any question about the try and accept? No? Okay. So, in Python, you have a power of what is called hierarchical function. That means you create a function inside function inside function. Okay. So, other programming language does not have this, and that's why this is a little bit strange for those who are already learning something. For example, in C you cannot do like this. Eh? In Java you cannot do like this. So this in Python you can do. That you can have a function inside function, another inside function. Okay. So how do you know it's inside? By the tab. Okay. The amount of the tab, you know that this is inside this one. The mid function mid is inside the top, and then function bottom is inside the mid. Okay. So okay, I will copy and paste here. Okay, the result is exactly this. Can you see now? When I said f top word, okay, this word will go become A. Right? A, the value of A is word. And then now B will say this is a magic word plus empty string here. Right? And then what it will do, it will return this one, mid B. Okay? So from line 2, the control of the program will go to line 8. Right? And then in line 8, we'll come back to line 3, which is to find that mid F mid B. What is B? B is magic word, right? And then inside this mid, B is magic word. Now you multiply by 2. Huh? And then you add is happening. Okay, magic word, multiply by 2 times. And then is happening, right? And then after line 4, where is the control will go? After line 4, where the control will go? Line, anyone knows? After line 4, where the control will go? No, will not go to line 5. Will go to line 7. Right? Because this line 5 is just definition, so it will not go. But it will go to line 7. From line 7, it will go back to line 5. In line 7, what is F bottom C? What is C? C is this one. Magic word is happening. So this is an array. C is an array. Okay? And then the bottom here, we return C itself and then adding with boom. Okay? Then it will return this F bottom C. It will return this one. So you will see F top here will return everything that is inside the hierarchical function. Is it clear or not? Okay. So this is not really used by any programming language, but this is important. Recursive function is a function that calls by itself. Okay. So example here is Fibonacci. I think you have practiced this last time, right? So any recursive function must have base value, otherwise it will never stop, right? So this part is the base value. If n is less than 2, then it will return n. Okay? So otherwise, it will call itself, okay, with different values. It will call itself with different values. Okay? So then you can see if we do a Fibonacci with range 1 to 20, you will get this value of Fibonacci. Okay, so last time we already discussed this and you practice also, right? Okay, so next, in Python, okay, there is a paradigm, it's called functional, okay, functional programming. So in functional programming, everything is a function. Okay, everything is a function. So using this, including variable is a function. Okay. So JavaScript, Python is one of the a few examples okay, that we can do functional programming paradigm. So in this case, we don't really have a function. So we call this function anonymous function. Okay, to create an anonymous function, you use lambda. Okay, this is based on lambda calculus. Okay, so lambda, you will have an argument of list and then the expression. Okay, and then you will equal it to the variable. For example, h equal to lambda x squared plus 1. Okay, you copy this. Let's do this in here. Oh. What does it mean? You define a variable, right, h, okay, to be equal to the function. Okay? Now you can put h of 5. Oh, 26, what is that? That 5 will enter as the input here, which is x, and then square it, which is 25, right? And then plus 1, that's why you get 26 here. Is it clear? So lambda is defining a function without naming that function. Okay? So this variable here is optional. Okay? So you create a function, okay, and then assign it to a variable. Now that variable becomes a function. Okay? So this is actually equivalent to this define a function of h. Yeah? So now you can also have several arguments. Okay? In this example, you can have several arguments a, x, and b, and then you will return this one. Okay, it will return a times x plus b. Okay. So yes. Go. This one. Lambda x mean you define an anonymous function. Anonymous function means a function without name. Right? You know anonymous. Okay? Meaning no name. Okay? So x in here is the input. The parameter input. Okay? This is the return value. The x squared plus 1 is the return value. Okay, so if you have only a very short function, you probably want to do it fast. Okay, instead of defining the function, you use lambda so that it's fast to program. So usually we use lambda if you have only one line of function. Okay, so the colon here means I have an input of x. Okay. This is the output of that function. So this is the input, x. This is the output, x squared plus 1. Yes, you can have an input of 2. For example, here. Oh, this is a 3 actually. Yeah? Affine. Okay. Affine here have 3 input. What is the input of affine? A, x, and b. Okay, the output is ax plus b. This is exactly the same as this one. Def affine ax b, and then you close it, and then you will say return a times x plus b. This is exactly the same thing. Okay, so instead of doing 2 lines like this, you can make it 1 line. This is just to shorten. Right? Is it clear or not? So, anonymous function is you assign it to a variable, and now that variable becomes a function. Right? But now look at the difference. Okay, let's call this affine 1 so that I will make it different. Okay. Now I will put affine, okay, whatever number, 1, 2, 3. I get 5, right? Again, I have affine, copy, affine 1, 1, 2, 3. Of course, it will give exactly the same, right? Okay. Now let's make it different. Now I create a new variable. Okay, I call this affine 2. Okay, affine 2, which is the same as affine. Okay, I create a new variable, not function. Okay. So, because I am doing it as variable, anonymous function here, okay, now I will do it exactly like that. So affine 2, okay, 1, 2, 3. Oh, it worked. So because this is a variable, now I can change the name. Right? It will refer to the same thing. Okay. But because this is a function, you cannot change the name. Right? If you want to change the name of the function, you need to redefine that function. Can you see the difference now? Okay, so there is another function, okay, it's called map function. Okay, basically this is to iterate. Map function is to iterate, okay, for all the element of the sequence, but this is very powerful function. Yeah, it will create an iterator, okay, based on function and sequence. Okay, so let's do this. Instead of A, B, and C here, okay, 1, 2, 3 here, now I will put A is actually a list. Okay, B, X is a list, and then B also a list, right? And then now I will map that affine a while ago with this. Wow. What you will do is, now you will assign one by one, okay, 3, what is this? Okay, 3a times x plus b, right? So that means 3 times 4 plus 5. Okay, 1 plus times 2 plus 3. Okay, one by one for each of the value in the list. Another example here of the mapping. Okay, say you have a lambda function of this one. Okay, this is a lambda function of x squared, right? And then now you have a sequence of 0 to 9. Okay, now you want to calculate the square of 0 to 9. So you get that. Is this clear or not? So mapping, okay, will map one by one, okay, all the value of this sequence into that function. Okay, so it will produce an iterator. So without this list, what will happen? You will get an object. Yeah? Without this list, you will get an object of map. Okay, you cannot see, right? So if you want to see it, then you put the list. Is it clear or not? If you have any questions, so go ahead. Okay, don't wait until you forget. So in here, okay, in this example, now we we can put the map the same as list comprehension. Okay, so in this case, instead of the value to the function, I create the value into many functions. Okay, so in this example, we imported sine, cos, tangent, so 3 functions, and then the pi is a number, right? So let's try this. So in here, you see this is an import format. Okay, this 3 function and this constant pi. Okay, now we define a function let's call this map function, okay, that we can actually put this function into x. This is the reverse of the map. Okay, so it will return the function of x where the function is in this list. What is this function? We don't know. It's up to you to define. It's the user who define it. Okay, so say the user define that function as sine, cos, and tangent. Right? So remember, yeah, from here until this line, so line 1 to 4 is the programmer who design it, right? Now the user will define this line 6 and 7. Okay? If you want to use this line 1 to 4, is you define that function. And then you set map function of the constant x, yeah, and then the list of function. Can you see it? So the meaning is, look, function you can even put in the list comprehension. It's not just the number. It's not just the constant. Okay, including function you can put it as in the list comprehension. Is this clear or not? So then of course you will create, if you run this, of course you will get the sine of pi over 2, right? What is this? This is the cos of sine pi over 2, 90 degree, right? And then this is the tangent of 90 degree, eh? Very big. And this is almost 0. Eh? Sine of 90 degrees 1, right? Okay. Is there any question so far? Now, if you want to create code that can code, right? So last time Matthew was asking me, can we actually create a code that can code? Yes. Okay. How to do that? You make the code in string, and then you just use this function, eval.string. Okay. Then automatically Python will run it. Okay. So if you can create the string that is code, okay, and then you call eval just one line, okay, then it will automatically run that code. Okay. So using eval string, you can run a string code. That means now you can code that can make a code. Clear or not? Okay. So the simplest is just like this, no? Say you have a 12.5, 13.5, and then you put it as a string, okay, by this quote, right? And then you set eval. So then it will become 26 points. Right? Now suppose you have this definition, right? H8 is equal to return of h squared plus 1. Okay, you remember this a while ago? Okay, so for example, h of 5 will be how much? Oh, 26. Okay, so 26. Now, what happened is now we eval. Okay, you know that h of 3 is how much? H of 3. 10. Okay, so let's do eval of h of 3 plus h of 5. But because this is eval, this must be string. Okay? So, now become 10 plus 26, 36. Is this clear or not clear? So, basically you can create any code. Okay? And because it's a string, then you can manipulate as a string. Right? And then suddenly you just call one time, it will run everything. Okay, up to here, all the function. Is it clear or not? Is there any question? So you have learned variable, you have learned how to control, you learn how to loop, right? And you know how to modularize all your code into one program called function, right? Now, the next level is called object-oriented programming. It's a paradigm. Okay? So, I will write here. So, OOP, oops, where is my drawing? Okay. OOP, object-oriented programming. Okay. So everything become object. So what is object? Okay, so now you need to differentiate between object, okay, versus class. Class. So class is a design of the object. Give example. The class is car. The class is vehicle. Okay. The object is, for example, Toyota. Okay. Toyota is a car. So the class is car. Okay. The object is Toyota car. Clear or not? The class is the design. Okay. The general term. The object is the implementation. Clear? Now, so basically, what you define in OOP is the class. Okay? Once you define the class, when you implement it into real things in the memory, okay, that is called object. Up to here, clear or not? Can you distinguish object and the class? The class is the blueprint. Okay? When you already build it, it's called object. Okay? Now, so basically if we talk about it, then basically class and object is the same thing, right? Okay? So, what is object or what is class inside here? Okay, what is object? Object consists of two things, okay? One is called data. Okay, one is called data. Yeah. The second one is called method. Okay, what is that data? Data is basically constant, right? Constant, okay, or variable. Yeah? Method is what is this? Function. Yeah? Okay. So an object consists of two things: data and method. Okay. So what is the data? The value of that variable, the constant. Okay. And then there's a method. So sometimes we don't call it data, we call it properties. Yeah? Maybe the term is property. So property is basically constant variable. Okay. And then method is function. So what is object in that case? Basically, object is the module, yeah, that consists of both data and function. You see? Function is just a method, right? So in function you have for example, y equal fx, x is the input, right? Y is the output, okay? So you have input, you have output, that's the function, okay? But inside here, inside the function, now, you have also data, property, okay? then also have many functions, not just one function. It's many functions. Okay? You have many functions, you have many data. You can put it together into one module. Okay? That module is called object. Okay? The design of that object is called class. Clear or not? As simple as that. So without this understanding, you will start confused yourself with all the terminology later on. Okay, ask question. Go. Oh, of course you. If you want to go to the toilet, you just go. Clear or not? Sia, Nifil, Tamara. Who else? Stephen. Is Darren here? Yeah, go. Really, what do you want to ask? Yeah, okay, I will close my audio.
So class is like how you use the function in the module. So you know what kind of class it is.
Okay, so there are many type of classes, but for this moment, okay, all you need to think about it is as simple as this. I'll give you examples so that you will see. Okay, everything in Python is a class. Okay, everything in Python is a class. Okay, so when you, for example, here, A equal A plus ABC, for example, okay, or I will just name it like this. X.
Sir, you haven't shared your screen.
I haven't shared my screen. Okay, can you see it? So I will name it A, B, C, D. Right? So X is A, B, C, D. So I want to know the type of X. Oh, it's a string. You see? This is an object, okay, of class string. Okay, let's change this. Now A become 1, 2, 3. X become 1, 2, 3. Okay, now I change this. X become 1, 2, 3. What is the type of X? Oh, become integer. So everything in Python is actually object. Okay. So if you want to know the class on object, you use type function. Yeah? Okay, how to define a class? Very easy. To define a class, you just name it class name, and then you can have an optional input. Yeah? If not, it's similar to function, right? Okay, in function you name it def, and then function name, and then the input, right? But in the class, the same thing, eh? Class, and then class name, and then optional input, okay? Now, if you want to define an object, okay, all you need to do is you give an object name and then call that class name earlier. Okay? Now, if you want to access the object property, the data, you will put the object name and then property name equal to a variable. Right? If you want to change the property, the value of the property, you can do it something like this. So the object name, the property name, and then the value. Yeah. Okay. Now, if you want to call the object method, the function inside that object, the same thing, method name, and then don't forget the difference between property and method is this, yeah? These two. What is this? The parenthesis. Okay, let's try, okay? So let's define this. I copy and paste this. I define my first class. Oh, okay? So I will define my first class. Okay, so let's give a name x equal my first class. Okay, so let's type x, right? Sorry, this one must be this. So let's type x. Oh, x is my first class. Right? So where is located? It's in the main. Okay? That's the main module of this Jupyter. Right? So x is defined as my first class is the type. So now you want to know what is xb? X dot b. Okay? What is x dot b mean? 8. Oh, where did it come from? Here. B is equal to 8, right? You define. Can you see it or not? So you define as data, right? So inside that class have a data, okay? B equal 8. So I want to know what is that B. So you just put x dot B. That means the property inside that class. Okay? Now you can also use the same thing here. You can define a function, right? Say, I call this my function 1. Okay? Okay, so I will put my function 1. Okay, so I will put x dot my function 1 here. And then what is the inside of my function should be a, right? Okay, let's call this a is a b, c, d, f. Or a, b, c, d. There, the argument is a, c, d. What does that come from? Where did it come from? From here, this print. Right? So now you want to say, what is x, b? Oh, suddenly xb changed without doing anything. Xb changed to 3. How can? A while ago xb was 8, right? Now after I call this function, xb value changed to 3. Where it come from? Here. Okay, line 4. When you call this function, that b earlier, that 8, now is modified to 3. Okay, so to tell that this function belong to this class, okay, always you put self in here. Okay? The name self itself is not important. You can name it yourself. Okay, but the first argument in any function inside the class represent that class. So then you will say self b equal 3 in here is the class property that changed inside this method. Why b is not 5? Why xb is not 5 but 3? Why? Okay. But we modify b equal 5, right? Yes, but that b equal 5 is inside this function. It's not inside this class. Can you see the scope? Is there any question? Is there any question? Is it really clear or not? Okay, so to find out what is available, okay, in the object, Okay, you can use dir function, yeah, or var function, okay, to show the variable and the values. So you can do this. Okay, let's type copy and paste here. Oh, where is my object? Oh, okay, sorry. X, yeah. Right? X is your object. Yeah? There. Inside, so the first print show the class name. That is class name is my first class. Show the property and the method here, right? So inside that class consists of this property, right? So if you want to put var x, that means show the attribute and its value. So this one, you have only attribute is b, okay? And if you want to know the value of that b, you use get attribute of x here. It is clear or not? Attribute is property. Yeah? So attribute is the same as property. Property attribute data is the same thing. Okay? Method function, that is the same thing. Class is just consists of method and attribute, or method and property. Clear? Is there any question? Is it clear or not? So I'll clear this whiteboard. Say you have property, x is 5, okay, and then you have a function of x, and then inside this you put as a box called class, right? So if you have several class in one module, okay, we call this a module. Yeah? A module is basically one file, right? If you have several files in your code, that is called package. Okay? So if you have several files, at least one file, that is called package. So that is how you create a hierarchy of modularity inside the code. Module is one file. Yeah. One module is one file. Huh? Okay. Is this clear or not? So up to here, is there any question? This is just the beginning. So okay, let me go to Lentera. In your course, you're supposed to have an UML. Is that correct? Oh, okay, here. Can you see this? I will show the screen. In Lentera, you have a unified modeling language. Okay, so go to this slide. Okay. So this is supposed to be before midterm. So, okay. So I will join to talk about this UML. So this is part of what is called software engineering. Okay. Next time I will discuss software engineering in more detail, but at least this is what you need to know. So UML is called Unified Modeling Language. Okay, you can search in Google anyway. And there are 14 diagrams. Okay. So this is proposed by IBM. Yeah. So this is the overview what we will discuss about it in this slide. Okay. So the current version of UML is version 2.5. Okay. So now UML is under control of what is called OMG, Object Management Group. Okay, so it's you can check this website. Okay, so what is UML? UML is a unified modeling language. Basically, you create a design of the software or a system, not just software, including the system, is using this diagram. So it's a standard diagram that you can use to express your idea. Okay? So why you use UML? If you use simple natural language, okay, sentence can be interpreted differently by different people. Right? For example, here you said, the system need to be large with 4 legs and a trunk. Okay? So in the perspective of the system designer, it's something like this. Okay? But the implementer may be thinking of this elephant. Right? So the problem with natural language is there is ambiguity, right, in the communication. So it creates confusion. That's why we need to standardize, okay, the notation. Using the informal notation can be confusing, right? Even though my intention with this diagram may be obvious, that okay, you may think differently, right? So ambiguity is the problem in communication. So with the modeling language, it's a diagram, right? With this formally defined the meaning, clearly defined, then we can ensure that everyone is reading the picture the same way. Okay? So then the communication is successful between the system designer and different stakeholders in here. Okay? That's why we need to have a standard. This is basically UML is a standard. Okay? It's not just the notation but also methodology. Okay? So, and it's not merely notation, it is the notation, meaning the world standard. Okay? Of IT professional, including the system engineer. Okay? We are going to this world standard called UML, yeah? Unified Modeling Language. So that's why you learn this, because this is important. Okay? So the title in this lesson is about more on UML, because look, UML itself have more than 1,000 pages. Okay? So to cover everything is impossible, right? So you read by yourself, but I will just highlight everything in this class, okay? So again, UML, Unified Modeling Language. So it's a language, okay? If an English language have more than 100,000 words, okay, what we presented here is only a small subset of the UML, okay? So we can have several view, okay? So we call this a 4+1 view. The important part here is what it's called use case view. Okay? In the use case, it's a diagram about the requirement of the software. Okay? this is how you communicate between the, uh, the designer of the software and the client. Okay? The person who want, for example, the manager or the business people who want this software. Okay? You need to represent it as use case. Okay? And then you can have what is called logical view. So in this case, you have class diagram, state machine diagram, interaction diagram. And then you can see the process inside the software. Okay? In that case, you will draw what is called activity diagram. Okay? Now, if you want to develop and you want to send this software to other people, we have what is called package and component diagram. Okay? And if you want to show abstract part of this, how you will deploy this system to others, then you will have deployment diagram and so on. So there are actually, at this point, I have 14 diagrams in UML. Okay? So, okay, in logical view, you have what is class diagram. So when you want to create a class, before you create a class, you draw this diagram first. Okay? By having this drawing, you start to communicate between you as designer and you as a programmer. Okay? The class diagram depicts the classes, okay? The interrelationship between classes. Okay? So how to draw class diagram? Very simple. Okay? You just put bank, for example, account, bank account class. So this is the class name, right? And then just a box like this. Okay. Now remember, in a class consists of two, right? Data and method. Okay, attribute and operation. So then you need to design the data, the attribute. Okay. For example, bank account class consists of account balance. Okay. What is the operation? The method, deposit and withdraw. So this is how you will design your program. Okay, you start with the class diagram. Okay, what class do you want to create first? So inside that class, what is the attribute? What is the operation? So this is called interface. Is it clear or not? So by creating the data and the method, the input and the output, you creating what is called interface, then the designer, you, for example, designer in Indonesia, right? Using this input and output, you can, you can hire somebody else in different countries, in different cities. Okay? Say the programmer is in Africa. Possible? Possible, right? Why? Because the interface is already clear. The input is clear, the output is clear. What's supposed to be done is clear. This is how you design the software. Okay? So this is example. So you can the class can consist only attribute, consist only operation, or both attribute and operation. You can also put it as just class name only. Okay. So different way to show a class is this. Okay. So then, if you want more detail, you can also put it, okay, with the colon. So what is this type? For example, the attribute is velocity. This should be a vector. Right? And then the position should be a vector. Okay. Steer amount, what is this? This is a function, right? The method. Okay. Name steer. The input is amount. The output is void. No output, no return value. Void means no return value. How about get position here? Get position method has no input, but it has output, which is a vector. So the data type matter. Is it clear? So this is the interface that you design. As a software architect, you will design this. So now if you want to say this is an object, right? Instead of class, this is not a class, this is an object. For example, if you want to put it an object, you put underscore. Okay? Bank account, colon, bank account class. This bank account here, okay, this bank account here, this is an object, which is an instance of bank account class. Okay? To distinguish object and class. Is it clear or not? So UML allows shorter notation. Okay? When there is no ambiguity, you just put bank account underscore. That means this is an object. Okay? And another way is to put just colon. Again, this is an object. Okay? Underscore. Yeah, the colon means instant of in this case. Okay, we are talking about the standard notation, so this is what we are discussing. Okay, now UML allow the what is called information hiding. Okay, so you want to know whether this method or this object or this data attribute, okay, is actually what is the scope, right? So you can put plus, minus, hash, and tilde. Okay, standard notation, this one. So plus means public. Yeah? The attribute or the operation is public. That means visible everywhere. Minus means private. It's only local within the scope. Hash means protected. Okay? In Python, we don't have this. Tilde means the package. Okay. This is an example. Okay. Minus account balance. What does that mean? Yes, that account balance is private within this bank account class. External, outside the class cannot see. Inside the class can see. Can you see that or not? The meaning of private means outside class, outside bank account class cannot see that account balance. Okay? Outside class of bank account can do deposit, can do withdraw. Okay? Inside that class, minus that means protected in what is local, right? That in account balance can be accessed within that class alone, but not outside. That's the meaning of minus here. Clear, yeah? This is an example, and this is the implementation in C. Okay. So you see the class, and then private. Okay, and this is the data type, right? Okay. So, this is another example. So later on, the class can inherit other class, right? Okay. Class can inherit other class. So for example, person, the class person consists of student or professor. This is a database, for example. Yeah? Okay, so that arrow here represent arrow with extend here mean this student is actually a person. Yeah? This professor here is actually a person. Clear or not? Okay. So, and then this is another class called course offering. So, these are the top here. What is this? This is the attribute. Yeah? The bottom here is the operation, the method. And this is the multiplicity. Okay. So, one student, zero or many students, yeah, can take course offering, right? And 0 or more students, one course offering or more can be taken by the student. Okay, this is the multiplicity. Later we'll discuss about it. So there are 5 relationships between classes. Okay. If you only have one class, it's not so useful. It is the interaction between classes that actually make the program useful, right? So there are 5 types of relationship that you can draw using your design of the software, okay? And we can talk later on about the multiplicity, constraint, discriminator, and so on. So let's discuss first about this type of relationship, okay? One is called aggregation. So the second one is called composition. The third one is generalization, association, and dependency. What is that? Okay. So when an object, okay, of one class work briefly with object of another class, that is called dependency. So if you want to two objects work together briefly only, okay, you draw an arrow with dash. Okay. Now, if one object of one class work with another object, so you draw association. Right? Now, if you draw a diamond, that means aggregation. What is that? Aggregation means one class own, okay, but share a reference to the object of another class. Okay. I'll give you an example in a moment. Okay, and then composition means one class contain object of another class. And the last one is inheritance, meaning when one class is a type of another class. Now this is the strongest relationship, and dependency is the lowest, the weakest relationship. Let's do that. So let's discuss one by one so that you can see more detail. Okay. Say a car consists of a chassis, an engine, wheel, and seat. Right. So this kind of consists of, that means own but share reference, right? So this is called aggregation. Is it clear or not? A car consists of a chassis, an engine, a wheel, and a seat. So then you draw the diamond. Consists of. One object consists of many other type of objects. Okay. Next. Okay. So an open diamond represents aggregation. Okay. That means the whole and the part. The car is the whole. Yeah? Okay. And then the chassis, the engine, the wheel, the seat are the part. Okay. So that is called aggregation. If you have a whole and the part, you model it as aggregation. Okay. So this is when a racing car is destroyed, the mesh is not destroyed. Okay. So the mesh object know nothing about the racing car object. So aggregation, okay, with this diamond, meaning that the two just share reference, but they are separate. Okay. In this example a while ago, if the chassis, okay, if the car have no chassis, maybe not working, but still exists. Right? So they just go together. Okay. And they can work together. Now, aggregation is a conceptual notion. Okay. Seeing an aggregation in a class should help you to understand the relationship between classes, and at informal level. But it doesn't give you any more formal information about how they must be implemented. Okay? It's just a concept that you want to tell the others about it. So the second relationship is called composition. Okay? In this relationship, you have what is called has a, contain. So in this case, the whole strongly own the part. Okay? Strongly own the part. Okay, I'll give you an example. A chessboard and the square of the chessboard. Okay? One chessboard consists of 64 squares. That is how you will say. Okay? One chessboard consists of 64 squares. So, this is called composition, which is stronger than aggregation, right? So, what happened? If in this kind of association, the part live and die together with the whole. Okay, so meaning that if the square is not exist, the chessboard does not exist either. Is it clear? Okay, the two of them must go together. Okay, if the chessboard is thrown away, all the 64 square in that board also thrown away. Okay, so how do you define a composition? The same thing, but you put a solid diamond, not open diamond, but solid diamond. Can you see it or not? The drawing. Okay, so this is an example. A block entry, okay, is made up of an introduction and a main body. Okay, so both section is actually part of the block entry itself, right? So if the block entry is deleted, then the part is also deleted. So composition is stronger. Both must exist together. Is this clear or not? Can you distinguish between composition and earlier with this aggregation? Aggregation, can you write it down? Aggregation means consists of. Okay? Composition means has a relationship. Okay? The third one is called generalization. Okay? An object is a specialized class of the more general class. So, in this case, the relationship is a. For example, a touring car is a racing car, right? A rally car or Formula One car is a racing car. Is a. How do you know its generalization? Look at the arrow. The arrow is something like this. Okay? Based on the arrow, you know that this is generalization, this is composition, this is aggregation. What is aggregation again? Consists of. Okay? What is a composition again? Yes. And then generalization is. Okay? You see, right? Okay. So, it's an abstract. For example, racing car is an abstract. Okay? So then generalization. Okay? It's a concept of abstract class sometimes. So implemented by, so Formula One car, okay, is a racing car. It's the same thing, yeah? This is the same thing. Okay. The next one is called inheritance. Yeah? Inheritance is exactly the same as generalization. Yeah. So here, the block entry and wiki page, right, is a article, right? Okay. Block entry is an article. Yeah? Wiki page is also an article. So this is the comment. Yeah? If you want to know within the UML, you can create a comment. So this is a comment. Okay, this kind of node is called a comment. So, okay, this is another example of what is called multiple inheritance. Okay, so yeah, Python allow multiple inheritance. So a dual purpose account here is a block account and wiki account combined. So this class dual purpose account, okay, inherited from block account and wiki account. In Python, what you will do if inherit is in the class optional entry. Okay, this is what you will put. Okay. I will give you example in Python. Where is the Python available? We close this. The Python, learning Python, right? The class. Oh. In the class, you can create an inheritance. Okay. Here is an example. Can you see it? No, I did not share. Oh my goodness. Oh, this is a class of called vehicles. Okay. Can you see this? Class vehicles. And then it has attribute wheel. Right? And then this is the definition. Okay. When you create a class, you must define, this is called constructor. So it's a special function with underscore like this. That is init, is initialize that vehicle function. That means you need to input the name of that vehicle. Okay. Now, I created another class called car. Of course, a car is a vehicle, isn't it? Inheritance. So how do you know that is inheritance? You can put here. Can you see that? A car is a vehicle. So automatically it will inherit all the attribute and the method of vehicles. You got it? Okay. When I put car is a vehicle, that means all the wheel of vehicle will be inherited in car. The name of the vehicle will be inherited in car. And then what you will do in the initial of this, when you created the car, you change the name, right? And then you change the number of wheel. Yeah. So now I create another class called bus. Again, the bus inherited from vehicles. Can you see that? Okay. Oh, when I said inherit, mean the bus will also have name and will also have wheel. Okay. Then what you will do is the name is the same as the super. That means the name of the vehicle, and then the wheel you change to 6. Instead of 0, you change to 6. Okay. Say now you create an object. Okay. Say my car is an object, right? My car is a car of the name Toyota. Okay. Look, I don't define anything. I just define car class vehicle, but I can put the name. Okay. It will become Toyota. How about the wheel? It will become Ford. So I create another object here, name it my bus. Okay. The name is Ford. Okay. Then the Ford vehicle will become 6 wheel. Okay. So I created here another object, my vehicle, right? Say vehicle Proton. What is the name? Proton, right? What is the wheel? 0. Why this is 0? Because this vehicle has defined the wheel is 0. Is it clear about inheritance, yes or no? Do you have any question? So far so good. Let's come back to the slide a while ago. So the next one is called association. Yeah? We have 5 relationship, right? A while ago, we have, what is that? The 5 relationship. We have dependency, we have association, we have aggregation, we have composition, we have inheritance in the class. Okay? We have discussed aggregation, composition, inheritance, but we did not discuss about association and dependency. So now we discuss about it. Cool. Association, okay? You will use association, it's just a line without an arrow. Okay? That means one class is working with other class. For example, radiologist will work with the lawyer. Okay? If you want to explain what is the relationship, you can create a triangle like this. Okay? Optional, this one. So the radiologist will consult the lawyer. This is how you will draw in the class diagram. Okay? So in your group project, you create this class diagram and all the UML diagram later. Okay? When you present it in April, you need to present your diagram. Okay? So if you want to get more detail, you can create a new class. Okay? That consult is actually another class in here. So that association can be explained, okay, with another class. So this is called association class. Okay? So student, okay, one or more students is taking 6 modules. The word is taking, okay, can be explained as another class. So the class name is taking, okay, which consists of marked integer. What is this? This is an attribute, right? Okay. So this is another example. Okay. So a block entry is associated with the author, okay, and the block account. So okay, one block account consists of many block entry. Yeah? The star here represent many. Okay, and you can have a association class of category. Okay. So this is just example of association is taken, is taking, is taken to, and so on. So okay. Okay, let's go to the next one. So a class A and B are associated if, okay, the object of class A send message or create or has an attribute, okay, that value will have related to the class B or receive a message. Okay. That kind of association, send message, create, has a receive, is actually part of the association. Okay. In short, yeah, if one object has to know something about another object, that is called association. Okay. So Now the last one of the relationship is work briefly with. So this is called dependency. Okay, so to draw the dependency, you can put a dash arrow. Okay, so next things in the class diagram is multiplicity. Okay, so what is multiplicity? It's a number of instances participating in the relationship. Okay, so we can specify the exact number, okay, or the range of number, okay, or arbitrary number. So you put a star here. Okay, so in UML, okay, infinity mean you put as asterisk. So 1 dot dot star, that means between 1 to infinity. Okay, this is an example. A car consists of one chassis, one engine, how many wheels? Yeah, 4 or 5, right? How many sunroof? 0 or 1. Okay. How many fuzzy dice? Many, right? Star mean many. How many seat? 2 or more. Okay, yeah? Clear, yeah? Multiplicity. Yeah? So you can do it by yourself. Oh, how about this one? Can you read this? A block account, one block account has how many block entry? Many. Okay. But each block entry only have one block account. Okay. That's the meaning of multiplicity there. The arrow is representing the navigability. Okay. So the one block account has, okay, many block entries. Okay, so it's not the other way around, right? So that is the arrow there representing the navigability. Okay, you can navigate within this. Okay, so a racing car need not to be aware of the spectator watching it, right? So racing car can have, one racing car can have many sponsors, but a driver, okay, will drive 0 or 1 racing car. Okay. Important here is you know how to read the diagram and then how to draw the diagram. Okay. Sometimes you want to do constraint, so you can put constraint with this kind of things. So, for example, mammal consists of dog and cat, right? But you put incomplete because mammal, of course, more than dog and cat. Okay? So you can, sometimes you can put an overlapping constraint like this. Okay? That means that an instance may be an instance of more than one subclass. Okay. Next is sometimes you create an open triangle, okay, to label that this is actually a discriminator, okay, a type rather than association. So, for example, investment consists of bond class or stock class. So this is representing the type. Okay. So as I mentioned earlier, you can put a note in UML. Okay, so that is the example and talking about class diagram. Is there any question about it? Boring? Because we are talking about standard, so Okay, this is just a brief. If you want to read by yourself, that's fine. Okay, but I'm just explaining this so that you will know. At least you know, then you can make it. Okay. So one of the most important diagram is called use case diagram. Okay. In use case diagram, when you will use case diagram, you use when you deal with the client. Say you want to create a software, okay, or create a system, right? So then you need to know what is the actor of that system. Okay, who will use that system? Okay, and then what is the role of that system? Okay, so drawing of this is called use case diagram. This is an example. Okay, say I have a system which consists of three type of actor. Okay, car matching member, credit card company, okay, or ABTS. I don't know what is that. So probably a company name. Okay, so and then the car matching member can do what? Can register, okay, agree with the car sharing, and then pay membership. Right? The credit card company will process the payment. So these are the use case that you need to define in the system. So the actor also can be inherited. For example, a manager is an employee, right? Correct? So then you can create an open triangle like that. Okay? So you can put a stereotype. Okay? This is a double angle like this is called stereotype. Okay? Which mean include or exclude. Okay? So this is an example. Okay? Say the actor is tax prepare. Okay? And then it will prepare form number this and number that. And then each of this form will include printing that form. So this is the use case diagram. Okay? So include relationship, meaning that you will include that functionality in the other use case. Okay? So here is an example. Okay? When the new car sharer added manually, here manually added, I will put here, right? The membership payment is always proceed at the same time. So this is include, that means it will process payment at the same time with manually added car sharer. Okay, but process payment is standalone use case. Can you see that or not? Look at this way. The software in Petra, including SIM and so on, have very bad design. I'm telling you the truth, right? Okay, why? Because the students who study IT or creating the software never learn about UML diagram, or they don't listen when they learn about this. Okay, why? Because they don't understand the meaning, the usefulness of this. Because this is actually the one that make the design very good. This is what makes the difference between engineer and a worker programmer. I'm telling you this. Programmer is just high school level. You understand? When you can create the design of the software, that is what makes you an engineer. Not to make a program. Okay? So if you want to make a program, design the program, then you need to know all this diagram, even though it is boring. Clear? Okay? So the next one is include. You understand the include meaning? You will include that together. Okay. And then the next one is called extend. Extend relationship, okay, is the variation that if you do this, okay, it will do the other. Okay. But it actually separate things. For example here, okay, a separate use case model of order burger, okay, and turn down the fries. Okay. So who will do the turn down the fries is the customer. Okay. Who will order the burger is the server, for example. Okay. And the turn down fries it will extend the order of burger. Turning down the fries. This is the situation when the dinner is ordering the burger, and then they turn down the fries. They don't want to buy fries. Possible, right? You want to order the burger, they will ask you, do you want to order the burger only or order burger plus fries? So, and then the customer said, no, I don't want the fries. So they turn down the fries. Actually, the fries is included in the burger, right? Right, in the packet. So the customer can turn down the fries. It's not the server. Correct or not? So this is an extension of ordering the burger. So when you create the use case diagram, it's important to put all the possible scenario. Okay? Without putting all the possible scenario, then you will not get a good design. That is very important. So for example, turn down the fries is one of the scenario, right? So you need to include that. Without that, the system will not be able to, if customer turn down the fries, they don't want to buy the fries. Oh, it's not possible, you will say like that. That's very funny. Because your system does not allow people not to buy fries. Yes, all possible scenario must be in the design. That's why making design is not easy, because you need to put all the possible scenario. Clear or not? Okay. So the diagram is just telling the extension here. So some use case optionally can be extended by another functionality. Okay. For example, here is process payment, right? So then you will say process payment using what? Using credit card or using debit card, right? So then this you use extend here, because that means optionally you can use credit card or debit card. Okay. Oh, up to here, is there any question? Use case is probably one of the most important diagram. Yeah, that you need to put all the scenario of the actor. Okay. So, for example, who will use your software, right? For example, yeah. Oh, you said, oh, user. Above user you have admin, right? Above admin you have probably super user. So of course that means user have certain functionality. Admin is probably also user, but have more functionality, isn't it? Correct. And then super user probably have more functionality than the admin, right? So different functionality is the one that you put in use cases. Is it clear or no? Okay. The diagram itself is so simple, just circle like that with include and extend, okay, and the actor. But the actual thing is more useful, because this is so simple that you can interact with your client. Okay? Next diagram is probably for you. If you want to show how the actor and the object interact within one system, okay? So then you use what is called sequence diagram or collaboration diagram. So I will show you in a moment. So in collaboration diagram is actually equivalent to sequence diagram. Okay, you put the sequence of the transfer of information. Okay, probably I will give you the example here. So this is the actor, right? The actor is a member, so book borrower. Okay, the actor must be a library member, right? And then we have association here. They want to copy. Okay, what copy? Copy of the book. Okay, so this is simple collaboration without interaction. Okay, now I will show you with the interaction. You will see, now you put arrow. Number 1 is okay to borrow or not. Okay, number 2 is to borrow, and then the book has been borrowed. Okay, so the label of the arrow here representing the interaction in the collaboration diagram. So, okay. Next is called sequence diagram. Again, this is an interaction between actor and the classes. Okay. So, in here, you check the order of the interaction. Okay. The vertical axis is time. Horizontal axis is either object, actor, or message. So, say this is the collaboration diagram. If you look at this, first, you know there are two actors. Okay? One is the registered user. The second is the customer service representative. Okay? And there is a website here as the object. Okay? And then look at the step. Number 1. Okay? The registered user report the forgotten password to the sales representative. Number 2, okay, the sales representative will ask the full name, right? Number 3, the registered user will provide the full name, and so on. Can you see the steps between the actor and the two actors and the website? So this diagram is called collaboration diagram. You can make it, right? Step by step in your system. Okay? So another way is called interaction diagram, or the sequence diagram is the same thing as before. Okay? The difference is now you put it into vertical and horizontal axis. Okay? Exactly the same. You see here, number 1, registered user will report the forgotten password to the customer service representative, right? And then the customer service representative will ask the full name, okay? And then registered user will provide the full name to the customer representative. And then customer representative will retrieve user information and so on. So these are the sequence. Okay. So using this sequence diagram, actually if you use Visio, all this UML diagram is inside Visio, you just drag and drop. Okay. So using the sequence diagram, you can see the interaction between one part of the system and the others, including the object and the actor. Is that clear or not? So this is my own example. Okay. So I give you example of my own example here. So this is my software, for example. Okay. You see here we create a pedestrian software, for example. Okay, this is the package, right? You see, and this is the scope. You see the package here. Okay, and the detail of the package. Okay, and then you see the class diagram. Okay, this circle mean we go to another part of the system. Okay, and you see created the class diagram again of it, the detail. Okay, this is what is called specification document. Okay, can you see that or not? Okay, so for the real project we do this. Okay. So okay, so let's continue. So the timing is important in sequence diagram. Okay. The major advantage of the sequence diagram over the collaboration diagram is that the passage of time you can show graphically. Okay. So here, so the member of the book, borrower, can borrow, okay, and check if it is okay to borrow or not. If yes, then can borrow, right? And look at this, the activation bar. Okay, I will show you. This is the activation bar. That means this is where the system alive. Can you see this or not? This is the activation bar, mean where the system alive. Part of the system that is alive. Okay? That is busy. Okay? So the vertical dimension in the sequence diagram represent the time. The horizontal represent the object or the rule. Okay? And this is the lifeline. Okay? The activation bar here represents the lifeline. Is it clear? Okay, I will share my screen. I do have Visio. So if you use Visio, for example, I think as a Petra student you can get that, right? So there is a UML. Okay, so this is example of UML use case. Can you see it? Okay, so you just click drag and drop. Okay, so this is an example. Now, can you see that? You can create the use case. This is the actor, you just change the name. Okay, and what is the use case you need to type here. Okay, and in Visio you can also have the, where is the software, right? There. You can have a sequence diagram, activity diagram, and so on. Can you see it? So sequence diagram. You can have activation, right? And the object lifeline and so on. So these are just drag and drop. Okay, clear or not? Okay, so you just search in here in Visio, for example. You can have an activity diagram, state machine, later we'll discuss, and the class diagram. So here is the class. So I create a new one. Right. So class diagram, you just drag and drop. See, right? So between all that, the one that I just discussed with you is already here. You just need to realize it. Okay. Say you want to have inheritance, right? you just click, and then this is another class, right? So then you put it in. Okay, yeah? In practice, that's what you will do. Okay, so next. Come back. Oh, the line here, okay, this represents the message. Okay, the arrow is the message between object or between the role, right? And then you can also put the return value, okay, using dash line. Okay, so you can also tell when the object is created, when it's deleted using that lifeline of the collaboration diagram or the sequence diagram. So example here, oh, the object is destroyed, so you just put destroyed. Okay, or this is new, so you can tell this is new in the collaboration diagram. Okay, so in the sequence diagram, you just put destroyed, so no more, right? So you can put new or destroyed, say new in here, new director of studies. So this is another example. So you can put, so first the buyer will give order detail, right, to the user interface, right? And then transfer the detail to the assemble order class. Right? And then the third one is the create an order, so there is a class named order class. Okay? And then it will return the new order, and then it will determine the price order using the price class, and so on. At the end, we have X here represent this is destroyed. This object is destroyed. Yeah? Out of the memory. Okay. Is this clear or not? You can also put constraint here. This is the example of constraint, right? Oh, this is another constraint that you can put. Okay, so this is just explanation of that. You can read by yourself. Oh, the next one is the guard. So this is important. What is the guard? Guard is, this is the example of guard. That means condition, if then. Okay? That using that condition, if that is true, then the message is sent. If false, the message will not be sent. Okay. So you can also put asterisk. Star move up one floor. That means you can move 0 or more floor. In this example, say you have a elevator controller, and then elevator door, right? So the elevator controller will move up one floor, but there is a star there. That means not just one floor. It can go beyond one floor because of the star here. Can you see it? Okay. And then once it already moved, the message will come back to the elevator controller. And then the controller is the one that send the message to open the door. And then the elevator door will open. So you see the elevator door lifeline is until here, meaning that is until the elevator controller say close the door, then the control come back to the elevator controller, and then again move one floor. Can you see it or not? Can you read the second diagram? Right? So using this second diagram, you can see how the operation, yeah, inside the system. You can draw them. Okay. The message itself, you can also have a message that return to itself. So, for example, okay to borrow. This is not. So, yeah, you can read by yourself here. Okay. So that is a message call itself is called self call. So this is just the explanation of it. You can read by yourself. And these are the type of arrow of the message. Okay. So different arrow will have the different meaning. So be careful. Okay. Okay. So arrow like this with block is called synchronous. Okay. Arrow open like this is called asynchronous, mean they can go parallel at the same time. Okay. And dot 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 like this is called return message. It's just written, and this is to create and to destroy. So only five types of arrow. So this is example. Okay. Asynchronous message invoke when the message caller here, okay, wait for the message receiver. Because this is synchronous, that means it will wait. Right? Until it finishes, then it will go. This is the example in code in, I used to use C, so this is the example in C. Asynchronous, meaning it does not wait. It can go in parallel. Yeah? Asynchronous message does not wait the message to return the value. Okay, so it goes in parallel. Okay, this is the example of the code. Okay, and return message is optional, so you will know that this is actually the end of the method. Okay. New and destroy is also part of it. Okay, so I think you can read by yourself. The next diagram is called state diagram. In Visio, you can just go to state diagram and then try. Okay. The state diagram is simple like this. What is the state of the system? And then there is a transition. Transition is the arrow. Okay? So if the state is off and the light switch is on, and the light switch is lifted, then the state become on, right? And then it's lower the switch from on become off. This is a very simple example. So in state diagram, you can see these 5 elements. Yeah? You have a state, you have transition, it is the arrow, the state is the node, okay? And you can have an event to trigger between event, and then there is a start and stop marker. Something like this. Okay? So, in the state diagram, you will have initial and final state. This is the initial and final state. And then you put all the states of the system in here, and how the state of one system change to another state of the system using the transition arrow. Okay. So you can draw a state diagram to represent your system as well. Okay, so I think we can stop up to here. And the material for your midterm exam is until here. From the beginning until state diagram. The midterm is in Lentera. Multiple choice. I don't know. I did not make it yet. So, you want all of the multiple choice? Okay. So you study well. Open book. Okay. Open everything. Open internet. Okay. So I hope you get but remember this. This is very important before you take the midterm. Yeah? Even though this is multiple choice, okay? For example, you have a multiple choice with 5 possible answer, right? So you need to answer all the correct question, the correct answer. Okay? If one of them is incorrect, so it will become minus. Yeah, minus point. Okay? So if you answer correctly all, then of course you get full mark. Okay? If you did not answer correctly, plus minus the full mark, that is positive, minus the penalty. So be very careful when you answer before you just tick, tick, tick. Okay. Is there any question? Probably you get all 100.